All right, so let's review what absolute value of a number means. So here we have the absolute value of 3 and the absolute value of negative 3. So you guys know the answer is 3 for both of those questions. Absolute value of 3 is 3. Absolute value of negative 3 is 3. The absolute value actually means the distance that that number is from 0. So the absolute value of 3 is 3 because 3 is 3 units away from 0. The absolute value of negative 3 is also 3 because it's 3 units away from 0. Okay, so absolute value means the distance that that number is away from 0 on the real number line. Hey, what about complex numbers? What's the absolute value of, say, 3 plus 4i? Okay, so we're going to take the same definition for absolute value on the real number line that you guys have always known. Absolute value just means distance from 0. So we're going to take the same definition for complex numbers. Except remember, complex numbers are not all on the real number line. They can be above the number line or below the number line. So let's graph 3 plus 4i. So the real part is 3. And the imaginary part is 4. So that point would be up here above the real number line. What's the absolute value of this complex number? Well, let's take the same definition as over here, where it was the distance from 0. Here we'll say that it's the absolute value of 3 plus 4i is its distance from 0, or from the origin. So the absolute value of 3 plus 4i is just going to be this distance. It's really easy to find that distance. We could draw a right triangle. And then, how long is this side? Well, this side is 3 units long. How long is this side? This side is 4 units long. So I'm just going to draw out another triangle here. So this side is 3, this side is 4. That's a right triangle. What their famous theorem applies to the length of sides of a right triangle, that would be the Pythagorean theorem, which says that 3 squared plus 4 squared equals this side squared. All right, so if we work that out, 3 squared plus 4 squared is equal to question mark squared. We would get 9 plus 16 mark squared, which would be 25, equal to question mark squared. Take the square root of both sides. Question mark would be square root of 25, which would be 5. So this side of the triangle is 5, so this distance is 5. Okay, so the absolute value of 3 plus 4i would be 5. And this absolute value is called the modulus. Okay, so that's just another word for absolute value, usually used when you're talking about complex numbers. So the modulus of 3 plus 4i is 5. All right, let's do another example. Let's find the modulus, or the absolute value, of 2 minus 6i. Okay, so let's plot this on the complex plane. So the real part is 2, and the imaginary part is negative 6. 1, 2, 3, 4, 5, 6. All right, so the modulus, or the absolute value of 2 minus 6i, would just be this distance. So let's call that question mark. So the modulus of 2 minus 6i is question mark. So this distance would be question mark. And how long is this side of the right triangle? Well, this side is 6 units long. This side is 2 units long. So we have a right triangle. We can apply the Pythagorean theorem, which says that 6 squared plus 2 squared is equal to question mark squared. So we have 36 plus 4 is equal to question mark squared. 40 is equal to question mark squared. And we take the square root of both sides, and we get question mark is equal to plus or minus the square root of 40. Okay, in the last example, I didn't put plus or minus, so I kind of skipped over something important. The true solution to this equation, of course, is plus or minus the square root of 40. But here we're talking about distance. Distances are always positive, so we're not going to want the minus. Okay, so we can get rid of that. We don't want the negative square root of 40 because distances are always positive. So we just want the principal square root of 40 or the positive square root. All right, let's simplify this a little. What's the biggest perfect square that would go into 40? That would be 4. So we got the square root of 4 times 10. We can break that apart. The square root of 4 and the square root of 10. And that would give us 2 square roots of 10. So the absolute value, or the modulus of 2 minus 6i, is 2 times the square root of 10. All right, so let's find the modulus, or the absolute value, of a plus bi, so a general complex number. Okay, so again, what we're wanting is its distance from 0. We're wanting this distance. That's a question mark. So think of a right triangle. This side of the triangle would be A units long. This side of the triangle would be B units long. So we apply the Pythagorean theorem, which says that A squared plus B squared is equal to question mark squared. And if we take the square root of both sides, we will get question mark equals a positive square root, because we're talking about distance, of A squared plus B squared. And so the modulus of A plus BI, notice, is just, you probably recognize that as the distance formula. Modulus of A plus BI is the square, or it's the sum of the square of the real part plus the imaginary part. Okay, so we square the real part, we square the imaginary part, and we take the square root, and that gives us the modulus of A plus BI. All right, so you guys try this one. W is the complex number -5 plus 6i. I want you to find the modulus of W. All right, so let's try this. So our formula for the modulus that we just found was the square root of the real part squared plus the imaginary part squared. So we have 25 plus 36. 25 plus 36 is 71, and I don't believe that we can simplify that any. So the absolute value of -5 plus 6i would be the square root of 71. Don't laugh at me too much. That's not 71, that's 61. Now I'm finished.